So if you have indeterminate form, that's when you can use L'Hopital's rule. So write down indeterminate form when, if you have 0 divided by 0 or infinity divided by infinity, when you're doing limits, they're called indeterminate form because you don't know whether the limit exists or not. So oftentimes we went through and we would do algebra to get rid of them. Like, here's some examples of what we have done previously. If we have this limit and you have some algebraic statement, but you can factor out something and it simplifies so that there's an x plus 1 that simplifies with an x plus 1 here. You simplify it and then you just plug in -1 and you get it. Or this one, we just kind of use the rule, and this is what they're saying you did, divide the numerator by x squared. Or we just knew that if they have the same leading coefficient, you just do 3/2, which made it a little bit faster for us. But, you know, doing a little bit of algebra, because if you plug in infinity right now, this gets infinitely large, and this one gets infinitely large. So that's indeterminate form because you have those two things. So there are some things you can do if you have algebra. This one, you could factor it. So mostly indeterminate form is what you're writing down is 0 divided by 0 or infinity divided by infinity. That's the main thing that you're trying to get out of this indeterminate form part. Like this one, if you couldn't think of how to factor this, then you could use L'Hopital's rule and it would make it way easier. So right now, this one they're factoring it and then you get 2. But L'Hopital's rule says if you have a function and as x approaches c, when you plug in c, you get indeterminate form. So either 0 over 0 or infinity over infinity, or maybe, you know, negative infinity over infinity, anything with the infinities dividing by each other. Then you can use L'Hopital's rule, and you can just, now it's not the quotient rule, it's just you just have the top, you take the derivative of the top, you take the derivative of the bottom, the limit is going to be the same. So the one we just looked at for just a second, that looked kind of hard because it would be hard to factor, was it had e to the 2x minus 1, and they ended up factoring it, and e to the x minus 1. And when you plugged in 0, the limit as x approaches 0, you first just try to do limits by plugging in 0 and see what it equals. So in this one, if I plug in 0, I get e to the 0, which is 1, minus 1 is 0, e to the 0, which is 1, minus 1 is 0. This is indeterminate form, and they factored it and simplified and then re-plugged it in. But instead of doing that, because I don't want to factor that, if you want to just take the derivative, then this is the same thing as the limit. What is the derivative of e to the 2x minus 1? Okay, so you have to do e to the 2x times 2, and the derivative of 1 is just 0. Okay, and then the bottom one is just going to be e to the x. So now what happens when I plug in 0? I get 2 times 1 over 1, so the limit just turns to 2 without having to do some crazy factoring. Kind of like it, so just look, don't watch, don't do anything, write it down yet, just remember indeterminate form and write down L'Hopital's rule. Here's this one, you plug in 0, you're dividing by 0, but when you take the derivative, the bottom just turns to 1. Right? Because right now it's indeterminate form, but when I take the derivative, it changes it so that the top, the derivative of this one was 2 e to the 2x like we just did over 1. You plug in 0, you get 2. So this one says this is an incorrect use of it because if you look at it, when you plug in 0, what do you get on the top? 1, and when you plug in 0 on the bottom, you get 0. Is 1 over 0 indeterminate form? No, so you can't use L'Hopital's rule on this. It has to be 0 divided by 0 or infinity divided by infinity. So this one is not a good use of it. And then what Weston was saying is if when you get done, it's still 0 over 0 or infinity over infinity, take the derivative again. As long as but it has to be indeterminate form in order for that to work. So as long as it's still indeterminate form, you can do that. So we did some crazy ones. Not crazy, but it worked with some other ones that we've done. Let's say I have the limit as x approaches 0, and we had some of these. And we just looked at the highest power of x, right? So on this one, we just said, okay, we're going to do the asymptotes kind of thing, the horizontal asymptotes. If this is the x to the 8, and this is the x to the 8, then this should be 7/9. Let's say you forgot that rule, and you just start, because right now if I plug in 0, I get 0 over 0, right? So it is indeterminate form. Let's take the derivative a few times and see what happens. This would be 9x squared and 7 plus 7 plus 15 x to the 4th. Is this indeterminate form right here? It's not, because I have that 7 there now, huh? So it would be 0 divided by 7. Okay, so yeah, we should have been using the lowest power. So in this one, ignore that, because we usually factor it out, right, on this one. We factor it out. So, do they have the same power? Well, let's change this one to 5x to the 12th or something. So now we would look at the lowest powers. They had to be matching. Yeah, well, this one would have worked out fine because it would have went to 0. Because I would have factored out an x. So this one is how we did it before. If it looks like this, we factor out an x. And then the top is still going to go to 0 once we plug it in. At the bottom, when we factor out an x, so once I simplified, yeah, this went to 0 over 7, so this one should have been 0. And notice what happens when we did this. We did the derivative, and so we still got 0 on the top once we redid this using hopital rule. And you plug in 0, you get 0 over 7, which is just 0. And if it wasn't, if they happen to have two the same, the fraction would reduce to the same fraction. So it does work if you freaking remember how to do limits, like I just did. Okay. As I look at this, the h is going to be my variable. So when you take the derivative, h is your variable. And right now when I plug in 0, what happens when I plug in 0? I get 8 times 1/2 plus 0 to the 8 minus 8 times 1/2 to the 8 over 0. I get 0 over 0. So this is indeterminate form. Now the question is, what happens when you take the derivative of both of these, the top and the bottom? What's the derivative of this? What do you have to do to take the derivative of that? Drop the 8 down. That, right? And times by the derivative of the inside, which is 1, okay? And then what about the derivative of this part right here? Do I have any variables? Is 0. And what's the bottom? What's the derivative of h? 1. Now can I plug in 0? Because this is going to be the same thing, the limit of this. So the top becomes becomes, when I plug in 0, 64 times 1/2 to the 7th. That's it, right? I don't know, if I did this, you could almost practice this without a calculator if you remember your powers of 2. 64 is 2 to what power? I just remembered 2 to the 5th because I made you guys memorize 2 to the 5th is 32. So this is 2 to the 6th over 2 to the 7th. So it should be next to on bottom, it should be that. So instead of memorizing crazy formulas, you just got to remember how to take the derivatives. Okay, what? So previously we did what for this? So we factored out x. Factored out x, so we went factor out an x, 3x plus 1, and factor out an x, 2 minus 5x. And then we simplified, right? And so now when I plug in 0, then I got 1/2, right? Okay. This, since when I plug in 0, I get 0 over 0, I could do hopital rule. So if I did that, what is the derivative of the first one?
6 times plus 1.
And 10x. Okay, now what happens when I plug in 0? I still get 1/2, so that works. And Abby had a good point. What if this would have been the limit as x approaches infinity? We just did what before when we approached infinity? But yeah, we looked at the x squared and we did the 3, the -5, and we just said it was -3/5 because we knew that that's where the asymptote was, right? If I plug in infinity, do I get infinity over infinity? Yeah. Yeah, so let's use hopital rule and see if it works for this one. See if we get -3/5. So I do this, I take the derivative, which was, we just did, right? It's going to work. So right now, what do I get when I plug in infinity? Do I still get infinity over infinity? Do I still get infinity over infinity? So it's still indeterminate form, so I can take the derivative again. What happens when I take the derivative again? You get 6. 6 over -10, which is -3/5, so it still works. Okay. Yeah, this one was taking the derivative again the second time. As I look at it, when I plug in 0, what do I get? I get 8 1/2 to the 8 minus 8 1/2 to the 8 over 0. I get 0 over 0, right? So I'm going to use L'Hopital's rule, and I'm going to take the derivative with respect to h. This is my variable, so I'm going to do the derivative with respect to h of the top and the derivative with respect to h of the bottom. So I still have h approaching 0, but what is the derivative if h is my variable? How do I take the derivative of that? What do I do with the power on the derivative? Just bring it down. Bring it down, increase it by 1. And what's the derivative of a constant? 0. 0, that's nice, that's good. What's the derivative of h? 1. Now what happens when I plug in 0? All I'm going to do, 8 times 8 is 64. 64 times 1/2 is 7. And then the top would be the natural log of 2 plus h over 2. You guys agree that's the same? I just put the h on the bottom instead of right there. So you've got to do the derivative of the top, derivative of the bottom, and that should be the same, so that maybe I can try to plug in 0 now. So the nice thing is that it makes that go 1. And now you just need to find the derivative of the other part. And what's the derivative of natural log? So if I do the derivative with respect to x of the natural log of u, so it's not the same, well, it's going to be what? U prime over u. So yeah, this is going to be, you can figure that one out. The other one, this one, you plug in 0. If I plug in 0 right here, it's the integral from 1 to 1, which is just 0, but it's integral from. So this one, you're going to have to do the same thing. So try this for just a second, everyone. Practice this one too after you finish this one. But remember that when you do the derivative of the